In this video, we'll go over LeetCode question number 572, subtree of another tree. Now, if you haven't already, I'd highly recommend you first watch my video on LeetCode number 100, same tree. This is because we actually use the solution in same tree to solve this subtree problem with just a little bit of extra logic, so you'll have to be familiar with that solution first. The link is in the description, so please go ahead and watch that and make sure you understand how it works. Okay, now moving on to this problem. Given the roots of two binary trees, root and subroot, we need to return true if there is a subtree of root with the same structure and node values of subroot, and return false otherwise. For example, if these were the two trees given, then in this case, we would return true since root has a subtree that is identical to subroot. On the other hand, if these were the two trees given, then we would return false, because even though it looks like subroot appears here, the node with a value of 2 is missing the child nodes, so subroot would not be considered a subtree of root. So you can see that this problem is very similar to LeetCode number 100, same tree. But the only difference is that instead of trying to figure out if the two trees are the same, we want to figure out if the subroot tree is the same tree as any of the subtrees of root. So now let's look at the code and solve this in Python. Let's say the root node of the top tree is root, and the root node of the bottom tree is subroot. Like I mentioned, we're going to be using the same solution from the same tree problem, but with just a little bit of extra logic. So over here, I've brought over the exact same function used to solve that problem, where P and Q are the two nodes passed in. Now, since this function uses recursion, and the outer function will use recursion too, it gets a little messy trying to visualize both at the same time. So what I'll do instead is, I'll assume you already know how to implement this function since you should have solved the same tree problem first. And I'll treat this function as a black box, where all you need to know is that this function returns true if P and Q are the same tree and returns false otherwise. This will make it easier to focus on the logic that's happening in the main function. So now let's move on. Our first base case will be if the root node is equal to none. In this problem, both the root and subroot are guaranteed to contain at least one node. So if the root is none, then that means we've gone all the way down to the end of a branch without finding a matching subtree. You'll see an example of this later, but for now just keep in mind that we return false in that case. Right now, root is not none, so we'll move on. Now it's time to check if root and subroot are the same tree. So let's call our helper function isSameTree, which will return true if root and subroot are the same tree. You can see that the two nodes right now have different values, so they are clearly not the same tree, and so this function call will return false. At this point, we'll now have to check if any of the subtrees of root are the same tree as subroot. So we'll end up returning true if the left subtree of root contains a subtree that is the same as subroot, or if the right subtree of root contains a subtree that is the same as subroot. Let's enter the first recursive call first. As usual, I'll leave a green dot here as a reminder of where we left off in the function where the green node is the root. So let's enter the recursive function call, and now root is the node in orange. It's the left subtree of our original root. Notice that subroot is still the same node and doesn't change. Now let's try again. Root is not equal to none, so now we'll check if root and subroot are the same tree. Again, you can see that they are not the same tree, so we'll return false. Now we have to go down another level, and let's start with the first recursive call. Again, I'll add an orange dot here since we're in the function where the orange dot is the root. And now let's enter that recursive call. But now notice that root is equal to none. That means we've reached the end of a branch without any success, so we can return false. We'll now exit this function call and return back to the function where the orange node is the root. And remember, this function call returned false. We still need to try the right subtree though, so let's pass in root.right and enter this function. This time, root is the none value on the right side, so this condition is true again, and we'll return false. Now we're back in the orange function, and this returned false. So now we're ready to go back up to the function where the green node is the root, and we'll return false or false, which just evaluates to false. So now we've returned to the green node, and this function call returned false. So now we know that subroot is not a subtree of any of the subtrees on the left side of root. But we still have to check the right side. So let's pass in root.right, and now root is the node in blue. Root is not none, and now when we check if root and subroot are the same tree, we can see that this is actually true. So the isSameTree function will traverse both trees and verify that they have the same structure and values. So because they are the same tree, this function call will now return true. And since this condition is true, we'll enter the if block and return true. Now we can go back up to our original function, and this call returned true. So finally, when we evaluate this statement, this becomes false or true, which evaluates to true. So we'll return true as our answer, since subroot is a subtree of root. And we're done.